Hello everyone, welcome to this tutorial of grid search. Machine learning algorithms include several hyperparameters like K in KNN, learning rate in regression, and many more. The values of these hyperparameters are not predefined, and thus it requires time and resources to fetch the just perfect values of these hyperparameters. Often, the general aspects of hyperparameter on a model are known, but how to best set a hyperparameter and combinations of interacting hyperparameters for a given dataset is challenging. There are often general heuristics or rules of thumb for configuring hyperparameters. Now, definitely, being the curious species that we are, this question had popped in the minds earlier. What if there would have been a method for hyperparameter optimization? An optimization procedure involves defining a search space. This can be thought of geometrically as an n-dimensional volume where each hyperparameter represents a different dimension and the scale of the dimension are the values that the hyperparameter may take on. Such a real valued, integer valued, or categorical. Now, search space is the volume to be searched where each dimension represents a hyperparameter and each point represents one model configuration. Now, grid search is a tuning algorithm that attempts to compute the optimum values of the hyperparameters. That is the goal that we have, right? And it is an exhaustive search that is performed on specific parameter values of the model. The model is also known as an estimator. Grid search is great for spot checking combinations that are known to perform well generally. Now, grid search refers to a technique used to identify the optimal parameters, as I told. Now, unlike parameters, finding hyperparameter in training data is unattainable. As such, to find the right hyperparameters, we create a model for each combination of hyperparameter. And thus, grid search is considered a very traditional hyperparameter optimization method since we are basically brute forcing all possible combinations. The models are then evaluated through cross-validation. Now, we had discussed cross-validation in the earlier tutorials wherein the data set has been divided into K folds. Now, we keep one of the fold and the rest of the fold goes into the test training set. And the one fold stays in the test set. Similarly, we keep the combinations of the folds and we thereafter we find out that what would be the correct value of the parameters wherein we are getting a better performance. So the model boasting the best accuracy is naturally considered to be the best. So let us move ahead and see the program for grid search. Herein we'll be as usual using scikitlearn library for the same, and we'll be calling neighbors dataset metrics and grid search CV. So we are loading our iris dataset and we are splitting it. Thereafter, here we'll be checking the best parameters for KNF, the previous thing that we had learned. Now, this is the parameter grid. Now, the choices for n neighbors have been given as 1, 5, 10, 15. Weights can either be uniform or distance. A metric should we use Euclidean metric or Manhattan metric. So in grid search, I'm passing my classifier, the parameter grid, and CV. So what this CV is? This CV stands here for cross validation. How many folds are we doing? Here we are doing 5 folds. And thereafter, we are fitting our train data into this. So let us just see the output. Now, the best parameters that this algorithm is choosing is that it is telling us the metric, Euclidean, neighbors, 5, and weights uniform is the best parameter that we can get. Now, let us see the prediction that we are getting. So this is the whole metrics that we have. So we are getting 98% of accuracy, which is quite well. These are the precision, recall, FN score, and just one wrong, wrongly labeled data we have in the confusion matrix. Now let us play around here a bit and see what are the different options do we have here. So just press Shift Tab and this thing. And thereafter here, as you can see, the parameters can be the estimator, param grid that we have just mentioned over here, then scoring, end jobs, pre-dispatch, then CV that we have given over here, and thereafter we have refit, and then we have purpose. We'll be exploring this part. So just write verbose, and see here it is written that if we write 1, the computation time for each fold and parameter candidate is displayed. So let us just write 1, right? And this is how we are getting fitting 5 folds for each 16 candidates, totaling 80 fits. This is the output that we are getting. If we keep verbose as 2, then this is the output that we are getting. For what does 2 says, the score is displayed. So every CV we are getting that how it is running for the neighbors and keeping Euclidean and the time. And for 3, it says the fold and candidate parameter indexes are also displayed. So this is how we are getting the output for verbose. Now we'll just not keep this, and let us take some different parameters. Like let me just have 3 as neighbors here, and let me add 6 or 7 and 13, and let me keep my CV as 3, and thereafter let us see that what output are we getting. So now it is saying that still my metric has changed to Manhattan. Neighbors, best neighbors is 5 and weights as uniform. And thereafter, my prediction score has reduced down to 96. Now, what if I change this to 7 folds? So again, our values are changing, which is our neighbors are 3 now, metric is Euclidean, and the accuracy that we are getting is still 96. So this is how grid search works for us. It uses the idea of cross validation, wherein we can give values of several parameters that we want, and it combines all these parameters and checks the performance and gives us the best parameter, which would give us the best performance. So this is how grid search works.